By the end of this lesson, you should be able to explain gas pressure, explain atmospheric pressure. What made the water remain in the glass and not fall out? Why doesn't the cardboard drop? We are surrounded by a mixture of gas called air. Air is held to the earth by gravity. This strong invisible force pulls the air downward, giving weight to the air molecules. The weight of the air molecules exerts a force upon the earth and everything on it. The force per unit area exerted by the atmosphere at any point within the gaseous envelope surrounding the Earth is called atmospheric pressure or air pressure. Why doesn't the piston drop down? Gases are made of tiny individual particles. Gas particles move rapidly and randomly. The molecules collide with one another, with the walls of the container, and with the surface of the piston in elastic collisions. The collisions of air molecules with the walls of the container and with the surface of the piston resulting in forces acting on them. When a gas molecule hits the surface of the wall of the container with a velocity v and bounces back with a negative velocity, there is a change of momentum takes place. According to the Newton's second law of motion, force equals to the rate of change of momentum. Hence, there is a force acting on the wall of the container. Pressure equals to force over area. Therefore, pressure is exerted on the wall of the container. A gauge with a moving pointer is always found at the top of oxygen cylinders. This is called the Bourdon Gauge, named after the French inventor Eugene Bourdon. The Bourdon Gauge can be used to measure gas pressure. Inside the gauge is a hollow metal tube. When the gas pressure inside the tube increases, the tube straightens out a little. The end of the tube is linked to a pointer which reads pressure on a circular scale. When the gas tap is open, the gas pressure increases. For small pressure differences, a U-tube manometer is used. It consists of a U-shaped tube containing a liquid of density ρ. Air pressure acts downwards on the liquid surface in both sides of the U-tube. The liquid levels are equal if the pressure at the two sides are equal. If the pressure at A is greater than the pressure at B, the level at A is lower than the level at B. If the pressure at A is smaller than the pressure at B, the level at A is higher than the level at B. A manometer can be used to measure gas pressure. The pressure of the gas pushes against the liquid in the tube. The difference in the liquid surface levels in the two manometer legs indicates the pressure difference from local atmosphere. The pressure difference between P1 and P2 is indicated by the difference between the liquid levels H. The pressure at B is equal to the atmospheric pressure and is equals to P2. The pressure at A equals to the gas pressure and is equal to P1 and is equals to P2 plus H rho G. What is the gas pressure when the difference in levels is 250 millimeters? Pressure at A is equal to gas pressure, equal to atmospheric pressure plus H rho G, equal to 102,500 Pascal. When the gas pressure increases, the difference between the liquid levels increases. What do you expect will happen? What do you think will happen to the can when it is heated? When the water in the can is heated, the steam produced replaces the air in the can. The molecules in the steam exert a pressure equal to the atmospheric pressure. When the can is removed from the heat, sealed by screwing on its cap tightly, and then quickly cooled by running cold water, the steam inside the can has condensed into a very small volume of water, leaving a partial vacuum behind, and the number of molecules per unit volume is reduced. The speed of the molecules is also reduced since the temperature of the can has been reduced. So, the pressure in the can is reduced. The external atmospheric pressure acts on the can and the can crumples. What made the water remain in the glass and not fall out? The atmospheric pressure acts on the surface of the cardboard. The force on the cardboard is greater than the weight of the water in the glass, pushing it up and holding up the water in the glass. A mercury barometer is an accurate and relatively simple way to measure changes in atmospheric pressure. The mercury and then upend it in a mercury dish. At sea level, the weight of the atmosphere forces mercury 760 millimeter up the glass tube. So, the atmospheric pressure is 760 millimeter mercury, or 0.76 meter mercury. The atmospheric pressure can also be calculated in Pascal unit using the equation of pressure. The density of the mercury is 13,600 kg per cubic meter, so the atmospheric pressure is 103,360 Pascal. The air pressure at any level in the atmosphere can be expressed as the total weight of air above a unit surface area at that level in the atmosphere. Higher in the atmosphere, there are fewer air molecules pressing down from above. Consequently, air pressure always decreases with increasing height above the ground. Because air can be compressed, the density of the air normally is greatest at the ground and decreases at higher altitudes. Atmospheric pressure can also be measured using an aneroid barometer. In an aneroid barometer, a partially evacuated metal drum expands or contracts in response to changes in air pressure. A series of levers and springs translates the up and down movement of the drum top into the circular motion of the pointers along the aneroid barometer's face.